So a few years ago, you may recall the first road video I ever did on this channel, where we visited Lake George, New York and dissected the percentages and averages behind the original arcade version of Deal or No Deal. Well, we were back in Lake George for a couple of days this summer.
It's Oreo's first road trip. It's Oreo's first road trip.
Suffice to say, Oreo was a big hit in the village with everybody that passed by. We also did another of our usual activities, taking the go-karts for a spin at Adventure Racing. It was Brianna's first time behind the wheel, but Oreo was a little confused.
Where are we, Oreo? Where's mommy?
Funny how he looks for where mommy is at all times, but couldn't spot her a single time she drove past us. He's a silly dog. Like and subscribe just so you can see more of him. Back to the point of this video though. I ventured back to Playland's arcade because I remembered another arcade ticket machine I wanted to do a mathematical deep dive with. Fortunately, they still had it. It's the Price is Right Plinko machine. The premise is simple. You drop a quarter in, it bounces down through the pegs onto a tray where you hope that it pushes other quarters over the edge onto another tray with even more quarters teetering on the brink. If any of those quarters should then get shoved over the ledge to their doom, you win tickets based on how many quarters fall. We tried it a couple of times. My effort didn't go too well.
Try to aim somewhere in the middle there. Let's see if that activates. Yeah, and it went in the owl.
B, however, had a little better luck.
Oh, shoot a heck knows. No, wait. Maybe the eye's not lighting up. Oh, got something to drop. That's tickets. We got some.
Oh, I thought we got more quarters.
No. You get tickets for every coin that drops.
But the part that I was more interested in was the bonus feature of the machine. Like the actual Plinko on TV, each coin ultimately drops in one of 6 final slots. Each of them lights up a letter in the word Plinko. When all 6 letters are lit, it triggers the Showcase Showdown bonus where the big wheel spins and awards up to an additional 1,000 tickets. Sweet! Now you only need to do that 99 more times to get that Nintendo Switch the prize counter is teasing you into thinking you could actually get a huge discount on. But even if you're not that ambitious and all you really want is a fidget slug, I mean, just look at it. Who needs something that spins when you can just make this lovely creature squirm in your hands all day? You want to try to activate the bonus with as few coins as possible. That means you need to try to drop each coin where it'll give you the best chance of landing in each letter slot. Now, it should be noted that everything I'm about to explain is going to ignore a few key parameters that can impact the results, such as the diameter of the coin compared to the width of each slot it's dropping through, the angle at which it hits each peg in the grid, and so on. If you want that kind of nuance, go bug Mark Rober. He's already rigged almost every other arcade game there is. Just kidding, Mark, if you ever see this. Love your stuff. Say hi to Fat Gus for me. Instead, for this video, we're going to assume that as the coin falls in a particular slot in each row, it has a randomly equal chance of falling strictly into one of the 2 slots that are directly under it. As such, there are a lot of different routes that the coin can take by the time it reaches the bottom. But just how many, and which ones are the most likely? Now there's the statistics I crave. The logic I approach this with involves a concept known as Pascal's triangle. The primary function of this diagram is to give a comprehensive table of the calculations you'd get for any combination formula that picks a group of R items from a master set of N items. But the math we need from the triangle is much more simplistic. See, a further look at the numbers in the table show that the numbers in each new row can be obtained by adding the 1 or 2 numbers that appear directly above each position. More important to us, these numbers also represent the number of downward paths that are possible to get from the top of the triangle to any specific position down below. And just to prove that it works, here's a mapping of each of the 6 routes it takes to get to that 6 in the 5th row. I wonder what other video game this reminds me of. So how does this translate to the Plinko grid from the arcade machine? As instead of a triangular arrangement, the top row has multiple slots you can drop the coin from. Well, as it turns out, That same addition scheme that Pascal's triangle uses can also be used to determine how many routes lead to each of the slots in the next row. You start by choosing which slot you want to drop the coin through. From there, map out the spread of which slots the coin can possibly reach. Then, beginning with a 1 at the top slot, start adding your way down. If there's only one number above a slot, carry it down. If there's two numbers above the slot, add them together and record the total there instead. And continue going row by row until you get to the bottom. So in this case, dropping the coin in slot number 2 has the best chance of landing in the P slot with a probability of 19 out of 41 drops making it there. You can then repeat this process for each of the other drop slots at the top of the grid. Predictably, when everything is done, it shows that your coin has the greatest chance of landing in the letter that is most directly below the slot you drop it from. This makes sense since in the original Pascal's triangle, the largest number in any row is found either at or directly touching the exact center of that row, directly below the lone slot at the top. It's not a guarantee that you'll win every time, but it's as good as you could hope for. So drop those coins into your heart's content, and here's hoping that the odds will forever be in your favor. And here's more Oreo. So please be sure to like this video so YouTube shares him with more people. Share this video with more people yourself so they can see Oreo. And subscribe to this channel for more math fun and more Oreo when new videos pop up. You can also find me on Twitter at Sapinski. And don't forget to visit Lake George too. It's amazing. I'm Brian Sapinski, and I'll see you again soon.